Now in this question we have to differentiate this function if 1, x lies in this interval, x lies in this interval, and third is x lies in this interval. So we have to differentiate this function, that is y is equal to this much. What we do is we compare the pattern of this question with a trigonometrical formula. Tangent of 3 theta is 3 tangent theta minus tangent cube theta over 1 minus 3 tangent square theta. So what we do is put x equal to tangent of theta. This implies y is equal to tan inverse 3 tangent theta minus tangent cube theta whole divided by 1 minus 3 tan square theta. And this is equal to tan inverse, and this is tangent of 3 theta. This is tangent of 3 theta. Now there is a restriction on x, therefore there is a restriction on theta. So before writing this as tan inverse tan is 3 theta, we must check whether 3 theta belongs to the range of this function or not. Now range of this function is, range of tangent inverse is minus pi by 2 to pi by 2. Therefore tan inverse can take values only within this interval. So we must check whether 3 theta lies in this interval or not. Now first interval is minus 1 by root 3 is less than x is less than 1 by root 3. This implies minus 1 by root 3 is less than tangent of theta, x is tangent of theta, is less than 1 by root 3. Now tangent of theta is 1 by root 3. This means theta must be pi by 6. Tangent of pi by 6 is 1 by root 3. So this must be tangent of minus pi by 6. Tangent of minus theta is minus tangent theta. And tangent of pi by 6 is 1 by root 3. So tangent of minus pi by 6 will be minus 1 by root 3. This is less than tangent of theta is less than tangent of pi by 6. Tangent of 30 degrees is 1 by root 3. And this implies tangent is a monotonically increasing function. Therefore we will have pi by 6 is less than theta is less than pi by 6. Minus pi by 6 is less than theta is less than pi by 6. Direction of the inequality will be maintained for monotonically increasing functions. It will be reversed for monotonically decreasing functions. So this must be this. And this implies minus, multiply this by 3. Minus pi by 2 is less than 3 theta is less than pi by 2. And this belongs to the range of this function. So we can write from 1, we can write 1 implies y is equal to tan inverse of tangent 3 theta, and this must be equal to 3 theta because this is within the range. So it can take values within its range. So this must be 3 and theta is tan inverse of x. X is tangent theta, therefore theta must be tan inverse x. So this must be tan inverse x. And therefore dy by dx must be equal to 3 into differential of tan inverse is 1 plus x square. So this is the answer. This is the differentiation. Now second is x is greater than 1 by root 3. This implies tangent theta is greater than 1 by root 3. This implies tangent theta is greater than tangent of, this is pi by 6. Now tangent theta is greater than 1 by root 3. That is from 1 by root 3 to infinity. Now tangent of pi by 6 is 1 by root 3 and tangent of pi by 2 is infinity. So the values of theta will lie from pi by 6 to pi by 2. Tangent of pi by 2 is infinity. So the values must be from 1 by root 3 to infinity. So pi by 6 to pi by 2. Therefore, theta must lie between pi by 6 is less than theta is less than pi by 2. It must be pi by 6 is less than theta is less than pi by 2. Tangent of pi by 6 is 1 by root 3 and tangent of pi by 2 is infinity. So this must be the interval in which theta lies. Now multiply this by 3. We will have pi by 2 is less than 3 theta is less than 3 pi by 2. Now this does not belong to the range of the function. So we must write tangent of 3 theta is equal to tangent of n pi plus 3 theta. This is the standard result. Tangent of alpha is equal to tangent of n pi plus alpha. Tangent of alpha is tangent of n pi plus alpha. So now we have to choose n such that this is within the range of tan inverse. Now let n be equal to pi. Then pi plus, this will be outside the range. This will be pi plus pi by 2. That is 3 pi by 2, which is not within the range. So try n equal to minus 1. N equal to minus 1. So this will be minus pi plus 3 theta. Minus pi plus 3 theta. To add minus pi throughout. If I add minus pi here, it will be minus pi by 2. It will be minus pi plus 3 theta. And 3 pi by 2 minus pi will be pi by 2. So this will lie between minus pi by 2 and pi by 2. So let n be equal to minus 1. This will be tan of minus pi plus 3 theta. And minus pi plus 3 theta, add minus pi here. So this implies 2 implies, now add minus pi. If I add minus pi, this will be minus pi by 2 is less than minus pi plus 3 theta, and this will be less than minus pi plus 3 pi by 2 is pi by 2. And this belongs to the range of this function. So we can write from 1 y is equal to tan inverse of tan 3 theta, and this is equal to tan inverse of tangent 3 theta can be written as tangent minus pi plus 3 theta, and minus pi plus 3 theta is within the range of this function. So we can write this as minus pi plus 3 theta. It can take values inside its range, and minus pi plus 3 theta is inside the range. And this is equal to minus pi plus 3 into theta. Theta is tan inverse x. Theta is tan inverse x. So this implies dy by dx is differential of minus pi. This is constant, so differential is 0. 0 plus 3 into tan inverse x. Differential of tan inverse x is 1 over 1 plus x square. So this is equal to 3 over 1 plus x square. So this is the differentiation. Now next is x is less than minus 1 by root 3. That is, tangent of theta is less than minus 1 by root 3. This means that tangent theta is less than minus 1 by root 3 means tangent theta lies between minus infinity and minus 1 by root 3. It is less than minus 1 by root 3. So it is from minus 1 by root 3 to minus infinity. Now value of tangent is minus 1 by root 3 at minus pi by 6. And tangent of minus pi by 2 is minus infinity. Tangent of minus pi by 6 is minus tangent pi by 6. And tangent of pi by 6 is 1 by root 3. So tangent of minus pi by 6 is minus 1 by root 3. And tangent of minus pi by 2 is minus infinity. So theta must lie between minus pi by 2 is less than theta is less than minus pi by 6. Multiply this by 3. We will have minus 3 pi by 2 is less than 3 theta is less than minus pi by 2. Now this is not within the range. So we must write tangent of 3 theta is equal to tan of n pi plus 3 theta. And choose n such that this is within the range. Now say n equal to 1. So pi plus 3 theta. Pi plus 3 theta. Add pi throughout. If I add pi, this will be minus pi by 2. And if I add pi here, it will be pi by 2. So this will be minus pi by 2 to pi by 2, which is within the range. So n equal to 1 is the correct choice. So we will have this equal to tan of pi plus 3 theta. Pi plus 3 theta. And pi plus 3 theta lies in minus pi by 2 is less than pi plus 3 theta is less than pi by 2. That is belongs to the range of f. Therefore, we can write y is equal to tan inverse of tangent of 3 theta. Tangent of 3 theta. And this can be written as tan inverse of tangent of 3 theta can be written as tangent of pi plus 3 theta. And this is within the range. So we write this as tan of pi plus 3 theta. This is equal to pi plus 3 theta. This is equal to pi plus 3 into tan inverse x. Theta is tan inverse x. So we differentiate this and we get dy by dx is equal to differentiation of this is 0 and differentiation of tan inverse x is 1 over 1 plus x square. So this is the differentiation. In this interval we must proceed as this. In this we must proceed as this. In this interval, minus 1 by root 3 to 1 by root 3, theta lies between minus pi by 6 to pi by 6. Minus pi by 6, pi by 6. And on multiplying by 3 theta, we get minus pi by 2 is less than 3 theta is less than pi by 2, which is within the range. And therefore, tan of tan inverse tangent 3 theta is 3 theta. This is within the range. This belongs to the range of f. So we can write this as 3 theta. But here tangent theta is greater than 1 by root 3. This means the values of tangent theta lie from 1 by root 3 to infinity. Now tangent of pi by 6 is 1 by root 3. And tangent of pi by 2 is infinity. Therefore, theta must lie between pi by 6 to pi by 2. Pi by 6 to pi by 2. And on multiplying by 3 theta, we get pi by 2. We have to obtain 3 theta. So we multiply by 3. So this will be pi by 2 is less than 3 theta is less than 3 pi by 2. This is not within the range. So we write tangent of 3 theta as this and choose n. So what we see is if I take n equal to 1, then this will be pi plus 3 theta. Pi plus 3 theta will not be in the range. So we try n equal to minus 1. So minus pi plus 3 theta. And minus pi plus 3 theta, add minus pi throughout. This will be minus pi plus pi by 2. Minus pi by 2 and minus pi plus 3 pi by 2 will be pi by 2. So this is within the range. So we can write y equal to tan inverse tangent of 3 theta equal to tan inverse tan of minus pi plus 3 theta, because this is not in the range but this is in the range. So this can be written as this. And in this case, tangent theta is less than minus 1 by root 3. Now, tangent theta is minus 1 by root 3 means theta is minus pi by 6. Tangent theta is less than minus 1 by root 3 means it lies between minus infinity to minus 1 by root 3. And tangent theta is minus infinity at minus pi by 2. So theta must lie between minus pi by 2 is less than theta is less than minus pi by 6. Multiply by 3, we get this. But this is not in the range of the function. So we write this as this and choose n so that this is within the range. So what we do is take n equal to 1. So pi plus 3 theta. Now add pi. If I add pi, this will be minus pi by 2 and this will be pi by 2. That is within the range. So pi plus 3 theta is in the range. So we write this as pi plus 3 theta. And this is within the range. Therefore, we can write this as this. Now in this question, we have to differentiate this function with respect to x, and there are certain conditions on x. X belongs to this interval, this interval, this interval, or this interval. So first of all, what we do is we compare the pattern of this term with the trigonometrical formula. Now, tangent of a plus b is tangent a plus tangent b, or 1 minus tangent a tangent b. If a and b are both equal, then we will have 2 tangent a over 1 minus tangent square a. We will have tangent a plus tangent a, that is 2 tangent a, or 1 minus tangent a tangent b, that is 1 minus tangent a into tangent a, that is 1 minus tangent square a. You can see this formula on the side sheet. Tangent of 2a is 2 tangent a over 1 minus tangent square a. And 1 minus tangent square a or 1 plus tangent square a is cos of 2a. It is cos of 2a. So what we see is if we substitute x equal to tangent of theta, this will become tangent of 2 theta. And this will become cos of 2 theta. So cos inverse cos 2 theta will be 2 theta. Tan inverse and tan 2 theta will be 2 theta. So what we do is we put x equal to tangent of theta. X equal to tangent theta. So y is equal to tan inverse 2 tangent theta over 1 minus tangent square theta plus cos inverse 1 minus tangent square theta over 1 plus tangent square theta. This is equal to, now tangent of 2 theta is 2 tangent theta over 1 minus tangent square theta. So this is tan inverse tangent of 2 theta plus cos inverse and 1 minus tangent square or 1 plus tangent square theta, you can see the side sheet. This is equal to cos of 2a. This is cos of 2 theta. Now tan inverse tan 2 theta will be 2 theta if 2 theta is in the range of this function. Now what we do is let this be equal to y1 and this be equal to y2, where y1 is equal to tan inverse of tangent 2 theta, and range of this is a subset of range of tangent inverse is minus pi by 2 to pi by 2. This range of y1 is a subset of minus pi by 2 to pi by 2. Range of tangent inverse is minus pi by 2 to pi by 2. And y2 is equal to cos inverse cos of 2 theta. And range of y2 is a subset of range of cos inverse is 0 to pi. So range of this function will be a subset of 0 to pi. Now first case is x is given to be in the interval 0 to 1. X belongs to, first is x belongs to 0, 1. That is 0 is less than x is less than 1. Now x is given to be tangent theta. So we call this as 1. Therefore 1 implies 0 is less than tangent of theta is less than 1. And this implies 0 is less than theta is less than pi by 4. Tangent of 0 is 0 and tangent of pi by 4 is 1. And this is a monotonically increasing function. So trend will be maintained. 0 is less than theta is less than pi by 4. Tangent at 0 is 0 and tangent at pi by 4 is 1. So for this, theta must lie in 0 to pi by 4. You can also keep the graph of this function in mind. So this implies 0 is less than 2 theta is less than pi by 2. And this belongs to subset of Ry1. This is within the range of y1. And this is also within the range of y2. This and this is also a subset of range of y2. This is in the range of y1 as well as y2. So we can write y1 is equal to tan inverse tangent of 2 theta. And this is equal to, because 2 theta is in the range of this function, therefore this must be equal to 2 theta. And y2 is equal to cos inverse cos of 2 theta. And 2 theta is within the range of y2. So this must be equal to 2 theta. And therefore from 2 we have 2 implies y is equal to y1 plus y2. y1 plus y2. So this implies y is equal to 2 theta plus 2 theta. That is y is equal to 4 theta. That is y is equal to 4 into. Now x is tangent theta. Therefore theta must be equal to tan inverse x. Therefore, theta must be equal to tan inverse x. Now we differentiate this. Therefore, dy by dx is equal to 4 into d by dx of tan inverse is 1 over 1 plus x. Okay, so this is the answer. This is the derivative of this function in this interval. Now we consider x belonging to 1 to infinity. And to make the idea clear, I am solving this parallel to this. I am solving this case parallel to this so that you can understand it better. Now second part is x belongs to 1 to infinity. X belongs to 1 to infinity. That is 1 is less than x is less than infinity. And this implies 1 is less than tangent of theta is less than infinity. Now tangent of pi by 4 is 1 and tangent of pi by 2 is infinity. Tangent is infinity at pi by 2 and 1 at pi by 4, and it is a monotonically increasing function. So we will have pi by 4 is less than theta is less than pi by 2, and this implies pi by 2 multiplied by 2. This is less than 2 theta is less than pi, because we have to check whether 2 theta is in the range of this or not. If it is in the range of this, then tan inverse tan 2 theta will be 2 theta. And if it is in the range of this, then this will be equal to 2 theta. Otherwise, we have to bring this in the range of tan inverse and this in the range of cos inverse. So what we now see is pi by 2 is less than 2 theta is less than pi. Now this is in the range of y2. But this is not in the range of y1. This is a subset of R y2, but not a subset of R y1. For y1, this is not within the range, and for y2, this is within the range. So for y2, this will be equal to 2 theta. And for this, we have to manipulate. Now y1 is equal to tan inverse of tangent to theta, and I have explained it to you earlier. We must write this as tan inverse tan of n pi plus alpha. Alpha is 2 theta. N pi plus alpha. Now we choose n such that this is within the range of y1. This is not in the range of y1. Now we write this as this and choose n such that this is within the range. So try n equal to say 1. N equal to 1. Then this is pi plus 2 theta. So pi plus 2 theta. Add pi. This is not within the range. This will be 3 pi by 2 and this will be 2 pi, which is not within the range. So try some other value of n. N equal to minus 1. So this will be minus pi plus 2 theta. Minus pi plus 2 theta. Subtract pi throughout. Pi by 2 minus pi is minus pi by 2. And pi minus pi is 0. So this will be minus pi by 2 is less than minus pi plus 2 theta is less than 0. So this will be within the range of y1. That is minus pi by 2 to pi by 2. Because we are having the interval minus pi by 2 to 0, which is within this. So minus pi by 2 is less than minus pi plus 2 theta is less than 0. So this is within the range. So n equal to minus 1 is the correct value. Let n be equal to minus 1. So this will be equal to tan inverse tan of minus pi plus 2 theta, minus pi plus 2 theta, and minus pi plus pi by 2 is minus pi by 2 is less than minus pi plus 2 theta is less than minus pi plus pi is 0, and this is a subset of R y 1. Therefore, we can write this as y1 can be written as minus pi plus 2 theta. Minus pi plus 2 theta. y1 is minus pi plus 2 theta. And we can write this as 2 theta because 2 theta is in the range of cos inverse theta. This is within the range of y2. So we can write this as 2 theta. And therefore 2 implies y is equal to y1 plus y2. y1 is minus pi plus 2 theta. Minus pi plus 2 theta. And y2 is 2 theta. And y2 is 2 theta. So this is 2 theta, and we have minus pi plus 4 theta. That is, this is equal to minus pi plus 4 tan inverse x. Theta is tan inverse x. So this is y is equal to minus pi plus 4 tan inverse x. And when we differentiate it, we get dy by dx is equal to minus pi. Differential of minus pi is 0, it being a constant. Plus 4, differential of tan inverse x is 4 over 1 plus x square. So we will have 4 over 1 plus x square, which is same as this. And therefore, dy by dx is equal to 4 over 1 plus x square, which is same as this. Now we take up the third case. Now third case is x belongs to minus 1 to 0. X belongs to minus 1, 0. Therefore, minus 1 is less than tangent theta is less than 0. X is tangent theta. So this implies, now tangent is minus 1 at minus pi by 4. So this will be minus pi by 4 is less than theta is less than tangent of 0 is 0. And since we have 2 theta as the angle, we multiply this by 2. So this will be minus pi by 2 is less than 2 theta is less than 0. Now range of y1 was minus pi by 2 to pi by 2. And range of y2 is 0 to pi. So this is not within the range of y2, which is 0 to pi. This is not a subset of 0 to pi. So we can write, therefore, y1 is equal to tan inverse of tan 2 theta, and since 2 theta is within the range of y1, so this will be equal to 2 theta. And y2 is equal to cos inverse of cos 2 theta. 2 theta is not in the range of y2, therefore we must write this as cos inverse cos of 2n pi plus minus alpha, that is 2 theta. I have explained this to you earlier. Now we have to choose n such that this is within the range of y2. We have to choose n such that this is within the range of y2. So what we do is, if we say take n equal to 1, then this will be 2 pi plus minus 2 theta. So 2 pi minus pi by 2. This will be 3 pi by 2. Will be less than 2 pi plus 2 theta is less than 2 pi, which is not within the range of. Therefore, n equal to 1 is not the correct choice. You can also try it for 2 pi minus 2 theta. It also does not lie in the range of y2. So choose, say, n equal to 0. N equal to 0. Then this will be cos 0 plus minus 2 theta. Minus 2 theta. So multiply this by minus 1. We will have 0 is less than minus 2 theta is less than pi by 2. Which is within the range of cos inverse. That is within the range of y2. Which is 0 to pi. So n equal to 0 is the correct choice. Let n be equal to 0. So this will be cos inverse and cos of minus 2 theta. Keep the negative sign. Because cos of 2 theta does not lie within the range, but minus 2 theta lies in the range. And we can say, multiply this, say this as 3. So 3 implies multiply 3 by minus 1. We will have 0 is less than, because we are multiplying by a negative number, so direction of inequality will be reversed. So 0 will come to this side. This will be minus 2 theta is less than pi by 2. And this is within the range of y2. And therefore we can write y2 as cos inverse cos of minus 2 theta. This is within the range, so we can write minus 2 theta. Say this as 4. Substituting 3 and 4 in 2. We will have y is equal to y1 plus y2. This is the number 2 equation. So we will have y1 is 2 theta and y2 is minus 2 theta. So this is 0. Therefore dy by dx is equal to 0. Now I take up the last case. That is x belongs to minus infinity to minus 1. Last case is x belongs to minus infinity to minus 1. I am solving this parallel to this to give you a better understanding. So this is minus infinity is less than x is less than minus 1. That is minus infinity is less than tangent theta is less than minus 1. Now tangent is minus infinity at minus pi by 2. Tangent of minus pi by 2 is minus infinity. And tangent of minus pi by 4 is minus 1. Tangent of minus theta is minus tangent theta. Therefore tangent of minus pi by 4 will be minus tangent pi by 4. And tangent pi by 4 is 1. So we will have minus 1. So tangent of minus pi by 2 is minus infinity and tangent of minus pi by 4 is minus 1. And therefore we can write this as minus pi by 2 is less than theta is less than minus pi by 4. And this is a monotonically increasing function. So this implies, now we need 2 theta. So multiply this by 2. Minus pi is less than 2 theta is less than minus pi by 2. This is not in the range of y1 as well as y2. So what we do is for y1, we write y1 is equal to tan inverse tangent of 2 theta. But 2 theta is not in the range of this. Range is a subset of minus pi by 2 to pi by 2. Therefore, this is not within the range. So we write this as tan inverse tan of n pi plus alpha. N pi plus alpha, alpha is 2 theta. Now we have to choose n such that this is within the range of y1. This is within the range of y1. So let n be equal to 1. N be equal to 1. So this will be pi plus 2 theta. We need pi plus 2 theta. So add pi throughout. This will be 0. Add pi here. This will be pi by 2. So this will be 0 to pi by 2. Which is within the range of y1. Which is minus pi by 2 to pi by 2. So n equal to 1 is the correct choice. Let n be equal to 1. So this will be equal to tan inverse tangent of pi plus 2 theta. And from 5 we have add pi here. This will be 0 is less than pi plus 2 theta is less than pi by 2. This inequality will change into this. And this is within the range of y1. So we can write y1 is equal to tan inverse tan of pi plus 2 theta. So this will be pi plus 2 theta. Say this as 6. Now for y2, we have y2 is equal to cos inverse cos of 2 theta. And 2 theta is in this interval, which is not within the range of y2. So we again simplify this as cos of, we will write this as 2n pi plus minus 2 theta. Alpha is 2 theta. That's. Now let n be equal to 0. For n equal to 0, try minus 2 theta. So this will be minus 2 theta. Pi by 2 is less than minus 2 theta multiplied by minus 1. We will have pi by 2 is less than minus 2 theta is less than pi. So pi by 2 to pi, which is within the range of y2. So n equal to 0 is the correct choice. And sign will be taken as minus. So this is cos inverse cos of minus 2 theta. And we know from 5 multiply this by minus 1. Now we are multiplying by the negative sign, so direction of inequality will change. Pi by 2 will come to the left. Pi by 2 is less than minus 2 theta is less than pi. And this is a subset of range of y2. This is a subset of range of y2. And therefore we can write this as y2 is equal to minus 2 theta. Substituting 6 and 7 in 1. What we get is y is equal to y1 plus y2. And this is equal to, now y1 is pi plus 2 theta. So this is pi plus 2 theta and y2 is minus 2 theta. So this is equal to pi. And therefore dy by dx will be equal to 0 because this is a constant. So in these two cases, the derivative is 0. But in the first two cases, derivative was 4 over 1 plus x square. It was 4 over 1 plus x square. So derivative will depend upon the interval in which x belongs. Now one more important thing, with a bit of practice you will be able to write this step directly from this. Now 2 theta here is not in the range of the function. It is not in the range of the function. But minus 2 theta is in the range. So with a small amount of practice you will be able to write this step directly from here. You will not be required to do this. This can be done orally. You can do this mentally and directly write this step from here. Cos inverse cos 2 theta. Now 2 theta is in this interval. If I multiply this by minus, it will be 0 is less than minus 2 theta is less than pi by 2, which is within the range. So you can directly write this from